Today, we will be creating types out of existing types using utilities that TypeScript has built in. In this episode of Too Long to Read TypeScript, we will be exploring some of the most popular utility types. These utility types help you reduce code duplication and enforce strict rules. I will be explaining how they work and how, under which circumstances you could use them. Our list contains partial, required, read-only, record, pick, omit, exclude, extract, and non-nullable. Somebody will say that utility types got you covered. Okay, please uncover me now. Thank you. Hey! These utility types are so common, and most likely you will be using them in your TypeScript projects. So you can use the red slider down below to jump to the ones that you care the most. And yeah, we have a lot to cover. So another episode of Too Long to Read TypeScript is starting, and I hope you will enjoy it. Hello friends, it's Nikos here, and thank you for joining me in this episode. If you are new to my channel, this is a series about TypeScript. Every week we are exploring a different feature of the language with practical examples and real-life scenarios. If these concepts sound Greek to you, then you are in the right channel. My goal is to help you become a professional TypeScript developer. So we've seen generics and how they can generalize our types to reduce code and to satisfy the type system. We also met conditional types in the previous episode, and you should check that episode because they are really, really cool. So TypeScript takes these concepts to another level by introducing some helpful built-in constraints that will allow you to fine-tune your types. So you can basically use them to generate new types. We will discover the most important ones in this episode, but I will suggest you to check the full list in the official documentation of the language. I will put the link in the description of this video. But first of all, let's answer the most important question. Why do we need utility types? So consider this interface track. We've seen this in multiple episodes, and it contains a couple of properties to describe a music track. Now, there are cases when you want to use this track type here, but with small little modifications. Let's say that you want to omit some of the properties, or you want to include new ones, or you want to enforce read-only, and many other different things. It's useful for every TypeScript developer to just understand and get familiar with all these utility types. So maybe someday you will use them in your project. It definitely will help you reduce a lot of code and improve code readability. It will also save you a lot of time, trust me. Let's start with the partial utility. So here we have a pretty similar track interface, which has an ID, a title, a release date, which is a number. It has this gerunds property, the isFavorite flag, and the times played number. So here we have a function that updates a track. So we give a track and we specify a part of this object, and then here we return the track, the original track, and the newly defined properties. This is a very common scenario that you want to have a setter that updates partially some of your object properties. And here the track, the existing track type is pretty obvious, it is track, but here fields to update is not exactly a track, as we will see, because if I have an original track and I try to pass, for example, only one of the properties, then I will get back this very nice error. So TypeScript is saying, this is not a track because it doesn't contain this, and that. So you use this question mark here for every of the properties. One way to approach this is to duplicate this track here, to have something like partial track, and add the question mark to every one of its properties. Now, if I use this partial track here, this will work perfectly fine. Of course, this duplicates our code because now we have two interfaces to deal with for the exact same object type. So instead of doing this duplication, there is the partial utility you can use in your code. And the syntax is pretty simple. All you have to do is use the partial utility. You don't have to import it. It's globally available in any TypeScript file. And we can use these brackets, these tags, let's say, to put our interface in. And basically this will solve the problem, because now we have a partial track object, and it doesn't have to include all the properties of our track. And this was our first utility type for today. We used an existing type to create a new type, maybe temporarily for this specific function, and of course we have less code to maintain. So less code to maintain, more time for Nikos. Okay, let's go to the next one. Our next utility type is called required, and it's pretty similar to partial. So here I have a kind of different function that gets a track, and it gets a required track. So here we have a track, and we use the strict update to provide a new object, and this will update all the values. So now, as you can see in our interface here, we have the isFavorite flag, which is an optional flag, and we have the times played, which is also optional. But since we use the required utility type, then I'm not allowed anymore to have these properties as optional. So if I remove some of these properties, TypeScript will complain, saying like times played is actually required, regardless if they have been declared as optional in the original type. So this utility type, all it's doing is create, let's say, a new type, and this type will not have any of these properties optional. So I have to specify a new value for the times played here. This will also prevent us from using this released at, which can take the undefined value. So undefined will not be an acceptable value for this property. And of course, if I forget this, it will complain as before. It's pretty useful in cases you want to ensure that the consumers of this function will pass all the objects, even the optional ones. The utility type Readonly helps you to protect object structures from being reassigned. And I think you are familiar with the read-only keyword in TypeScript. For example, here we have this user interface, and if we want, we can specify that this ID property is a read-only property. So if I declare one random object user, then I cannot basically reassign this ID property to something else, because TypeScript will basically complain here, since this is a read-only property. Similar to read-only properties, we can have read-only types. And this is where it gets interesting. So here, for example, we have the addUser function, which accepts a list of users, and it accepts the new user, and it pushes the new user in our array. So there's something wrong with this function. It's not actually a pure function, right? Because this method here will mutate the user's array. So here we are returning the existing users array mutated, and this is definitely not a good practice, especially if you are using a Redux or some kind of other state management or some similar tool that requires pure functions. And to solve this, we can introduce the read-only here. So basically, I can say that I want the user to be read-only, and now TypeScript will complain. It will actually tell me that push does not exist in the read-only user type. Basically, they completely removed all the methods from this definition that mutate the array. And this is really cool. There is a very nice hint here. If you want to simplify it a bit, there is another utility type which is called read-only array, and you don't need to pass these brackets here. So this is kind of nicer. Of course, if you do want the brackets, you can actually use the read-only keyword, which will have the same exact result. Now let's fix this function to return fresh version of the user's array and including the new user. And yeah, problem solved. Now be careful. The read-only can only prevent you at the top level of the properties. It doesn't perform any deep check. So here, for example, I have a similar object structure, but I have broke the ID property into an object structure, and I have separately a property for my number and the letter that forms an ID. And although read-only will protect you in the top level, it will not protect you from the levels that are deeply nested. I have some bad and good news here. The bad news is that TypeScript doesn't contain any built-in utility type to help you with this situation, but you can write one by yourself. One of my favorite utility types is called record, and I have seen this in multiple use cases. So here, for example, what if we had this enum, which is like a type enum and has these three different conditions, like this is a status loading indicator, and we have, for example, idle, we have loading, and we have failed. So now let's imagine that we are implementing a button, and the button can be idle, so the user hasn't pressed the button yet, or if I click on the button and it's loading, I can see a loading spinner, and if I have an error, I must see some kind of a warning sign. How to implement something like that? Well, this is very easy. You have these loading statuses here, and for every loading status, you need to specify which icon will be visible on screen. So that's why we need this interface icon, which has apparently the name of this icon from our icon library and the color, let's say, of the button itself. Then what I have to do is create a list of icons and assign this object structure here. So for each of the loading statuses, we have an icon that represents how this status will be displayed on the screen. So far so good. But how you actually add types to protect this object structure here? It will be somehow nice. Of course, we can use generics to create some object structure, but it will be nice if we can reuse these two existing types. And every time we make a change in these types, then it will be reflected in our type system. So TypeScript will make sure that this icons structure here has the appropriate statuses and the appropriate properties for every icon. And this is how record can help us. So record accepts two types. One is the type that contains all of our keys. For example, this time is our loading statuses, and for us this is the icon. And now you have it. So basically we were able to reuse these two types to describe this object structure here. How nice, how clean this code is, right? And of course, if you forget, if you omit some of these statuses, then TypeScript will complain, saying that, you know, this idle is missing from your record type. Pretty picky. Speaking of picky stuff, we have our pick utility type. And this is very similar to the partial utility type, but it gives you a bit more control over the properties you want to actually have. So for example, here I have the interface track, and let's imagine that my goal is to have a type track plays, and which will only include the ID property and the times played. All the other properties should not be allowed. And you can imagine multiple ways we can use this partial, let's say, track object structure in our code. So in order to do that, this is the hard-coded version, but we've seen a better way. We can use the partial track to define a partial track. And actually this will work perfectly fine. So if I have here, for example, plays, an object of track plays, then I can basically have partially what I want. But this is partially what I want, because if I try, for example, to copy these zerns here, then actually TypeScript will not really complain, because this satisfies our condition here that this is a partial version of our track. So we can be a bit more specific of what we want exactly to achieve here. And we can use the pick utility type. The first argument is basically, again, the object structure that we want to use, and then we can specify the keys, the properties within this object structure. So here I'm using a union to specify that I want the ID and the times played. And this, my friends, will work perfectly fine. So now my zerns property is not acceptable here, so I should remove it. And here you go. This is another very helpful utility type. The exact opposite of the pick utility type is called omit. So here, for example, if you don't want to select to pick some of the properties, and you want basically the whole object but to omit some of the properties, you can use omit. And this works very similar to the pick utility type. You specify the object structure and you specify a union with all the properties you want to omit. And now this is my track without zerns, for example, and if I go here and specify zerns property, then this will not work, because basically this is the exact copy of the track interface without the zerns. Pretty basic. So now be careful, because if you do have another object, let's say plays with zerns, and you try to assign this object to plays, which is a track without zerns, TypeScript will basically allow you here, because remember what we said, an interface is the minimum requirement for an object. It's not the actual object, right? So this will perfectly work fine. But if you specifically try to say that, you know what, this is also a track without zerns, then TypeScript will display an error. This is a fundamental feature of TypeScript. It doesn't have to do with the omit utility type, but it's good to remember. Now, similar to pick and omit, which work perfectly with object structures, we have exclude and extract, which work perfectly with enum types, and specifically with type enums. So here we have a list of zerns, and we have all. It's a collection of the ones that we support in our music player. And what if we want to have a type that stores only the commercial ones? Because these are the zerns we would like to play in our radio. And to do that, we can actually use the exclude utility type. And here we specify the original type, which is the zerns, and the union of the options that I want to exclude. So for example, this can be jazz and metal. Unfortunately, these are some music zerns that you will not listen on a charge radio. In a similar way, I can have, for example, non-commercial zones, and I can use the extract utility type to basically to pick the key values that match with the given union. So for example, for me this will be rock, instrumental, and OST. Now if we hover over here, we will see that TypeScript excluded jazz and metal from our original zones, and this resulted to have this very nice commercial zones here, and the extract is taking our zones and it filters by the list that we specify in our union here. So if I hover over, you will see that only rock is in that list, because these two zones don't belong to the actual zones type. And this means that you can use whatever types you want and TypeScript will not complain. Now, there are situations when you don't accept null or undefined as values in one of your functions. And if you're not familiar with these nullable types, then you should definitely watch my previous episode about the structural type system of TypeScript, which explained this concept very well. So another very useful utility type of TypeScript is called Nonnullable. And here's an example. We have, for example, track duration, which can be a number. It can be also undefined and null. So this means that I can perfectly come here and say that null duration is basically null. And here we have this double duration function, which accepts the duration number and it basically multiplies it by 2. So here TypeScript complains because this object, this duration parameter here, can be actually null or undefined, and it's not really good to multiply null or undefined. So to solve that, I can go here and say that this is a non-nullable track duration. And this is basically a copy of the original track duration type with these two nullable types removed. So only number is allowed. And yeah, now this works perfectly fine. And yes, this will not throw any errors anymore. But what will happen if I try to call the double duration function with the null duration, which is currently null? Well, this will actually cause another error. So we basically moved the error, we moved this logic to the consumers. And now we know that, you know what, this null is not assignable to a parameter of type number. Here is not really useful because I can say that duration is a number and simplify the logic, but this can be very useful in applications that use older versions of TypeScript in which the strict null checks flag is set to false, or in basically any project that you have set the strict flag to false. In this project, you really want to check your custom types if they have any nullable values. As we've seen, utility types can help you reuse existing types and modify them according to your needs. So this not only reduces code duplication because you only need to declare these original types once, but it also helps you enforce strict policies in your functions, methods, or anywhere in your code. So these were all built-in utility types that TypeScript offers out of the box, like no strings attached. But utility types don't stop there. There are also plenty of libraries out there with a variety of utility types for any use case. And remember, TypeScript is an open source language, so don't forget to command-click in one of the utility types and check its implementation. Because here you can basically see, you can get ideas of how you can create your own, and it will also help you understand the mechanics of the language. It's a very nice way to learn TypeScript. I may return to this topic later in the future because I want to present you some utility types that I personally like. So which are your favorite utility types? Write me in the comments down below, and what else you would like to see in the following episodes. That's anything you can think of. Don't miss my blog post about utility types. You can find everything I presented you in this video, including the coding examples. It's a nice way to review what we've learned and to keep as a reference. Now, if you want to learn TypeScript, you don't need to pay any money, you don't need to have any subscription, you don't need to buy anything. This series is like a free course designed to convert you from a person who haven't used TypeScript to a professional TypeScript engineer. I have created a YouTube playlist with all the videos of this series, and I will put it in the description of this video. For one more time, thank you for watching this video and for supporting my channel. Have a creative day, my friends, and see you in the next one.